All right, so hang with me for the first 27 minutes. Okay? Then it will get easier, I promise. But we got to push through that first 27 minutes in order to get there. Okay? All right? I promise. It'll be whoa at the end. Okay? All right. So, yesterday we started the law of sines. And we said that it's a way to solve a non-right triangle. Solving a non-right triangle means that you're going to be given 3 parts. You have to find 3 parts. Okay? Now, there are many different ways. 6 different ways to give those 3 parts. Okay? We're going to go through those different ways today. That's the 27 minutes, is getting through them and figuring out how you can solve those different things, how many triangles you get from it. Okay? All right. So, first off is the side, side, side case. Okay? That would be where you are given the 3 sides of the triangle. Okay? And that's cool. You get to use what's called the law of cosines. And the cool thing is only one triangle is formed when it's a side, side, side case. Okay? We haven't gotten to the law of cosines yet. We will get to it next week, Wednesday. Okay? Today we're going to do more law of sines. Tomorrow we're going to do more law of sines and some 5.2. Monday we're going to review 5.1, 5.2. Tuesday you're going to test 5.1, 5.2. Wednesday we'll do law of cosines. Okay? Alright? So this case, this number 1 case, it's a next week case. So I'm not really going to spend much time on that one. Okay? Side, angle, side type case. I still can't use the law of, oops, that should have been blue. I still can't use the law of sines here on this one because, oops, rotate it around. Or just, I can't use the law of sines on this one because I don't have that complete angle with its opposite side fraction. So this also is a law of cosines. And the nice thing about it is you still only get one triangle. Okay? Alright? So you only get one triangle coming out of that one also. Okay? But again, that's next week as the 8th graders walk by. Okay? It was Claire. Claire B. So, alright? Angle, side, angle case. So now I'm going to be given 2 angles and the side in betwixt them. Okay? So if I extend this out here now, can I get that 3rd angle? Yeah, because the 3 angles of a triangle add up to be 180. So I can get that angle right there, and I'm good there. And now I've got a complete fraction for the law of sines. So this one I can use the law of sines. Okay? The cool part about if it's angle, side, angle, one triangle is possible. Okay? Angle, angle, side. So now I would have an angle here and an angle here and a side that's not in between them. if I combine those two, I have my complete set, or my complete fraction, for the law of sines. So we could use the law of sines here. And the nice thing is, we still get one triangle. Okay. Those are the four easy ones, because they only produce one triangle each. Okay. Side, 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 we use law of cosines. We'll talk about that next week. Side, angle, side, use law of cosines. Again, next week. The other two, angle, side, angle, 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 side, we can use the law of sines because we could easily get that third angle in both triangles. Okay? Right? And then we have a complete fraction. Okay? What about angle, angle, angle? What about angle, angle, angle? Can I solve that triangle? I intentionally set up these two triangles so that the top angles were the same. Oops. And both bottom angles were the same. So can I solve for that triangle? No. Okay? Can't do it because I get similar triangles. We need at least one side. Okay? You have to get a side as one of your three givens. You can get two sides, you can get three sides, but you got to get at least one side as your given. Otherwise, you can't do it. Okay? Now, that leaves, so that's 5 of them. 4 of them produce a triangle. The fifth one produces a triangle, but it's not a locked triangle. It's an ambiguous, or I shouldn't even say ambiguous because that's a different word that we're going to use later on. It's a flexible triangle. Okay? So you might have it as a smaller one, I might have it as a bigger one. We all use the same angles, but okay, it doesn't work out. So sometimes there's the angle side side case. Okay? So the angle side side case is an angle here, a side there, and a side there. Okay? Now, I will tell you that we will be calling this side the opposite side, and we'll be calling this side the adjacent side. We're going to steal right triangle Triggs terminology just to make it easier for us. Okay? All right? So if that's the case, can I use the law of sines? Yeah, because I have that one complete fraction with the angle and its opposite side. Okay? And so I can do that. So what I would like you to do now is I would like you to find me just angle B in this angle side side triangle. Oklahoma, where the wind comes sweeping across the plain. The sine of 20.5 degrees divided by 12 is equal to the sine of angle B divided by 31. Okay? So then the sine of angle B is 31 times the sine of 20.5 degrees divided by 12. So angle B is the inverse sine of that, which is 115.217 degrees. Yes?
How do you convert again from radians to...
Multiply by 180 and divide by pi. Yes? Everybody got 115.217 degrees? What'd you get? You didn't even do it. You just copied mine, didn't you? Well, get your calculator out and calculate it for me. Uh-oh, what'd you get? 64? 64? Something's wrong here. Come on, do it again. Get 115.217. Try it again. This time, actually try it with pushing in your calculator. You should get 115.217. Try it again. What did you say? 64 point. Get a calculator out and do it. What you did? Don't tell me you got 115 because I know you didn't. I know you didn't do it that way. Because I'm doing this intentionally. Because when I did it, I got 64.7832. Oh, you did something wrong. I hate to break it to you. Okay? Check my answer once. Okay? So let's go back to the law of sines. So the sine of 20.5 degrees divided by 12 equals the sine of 115.217 degrees divided by 31. Check that fraction to make sure that that's a true proportion. Okay? Multiply 31 times the sine of 20.5 degrees divided by 12 divided by the sine of 115.217 and you should get 1.
How do you change the calculator from radians to degrees?
Gotta go into the menu section. Or just use the degree symbol. Since you're dividing everything out, it should equal 1. Yes? Ruh-roh. So who's right? You guys, because there's, what did I say, 13 of you? Or me, because I'm always right? Who's right? We're both right. Okay? This is where that ambiguous case comes in. Okay? I intentionally did that this way so that we didn't get the same answers. Because when I did it, I got 64.7832 on my calculator. But I knew that this was an ambiguous case. So let's dive in to what an ambiguous case is. Ambiguous is a fancy word for more than one possible interpretation. Okay? So there's more than one outcome. Okay? 2 or more meanings. Okay? It's ambiguous. Okay? So, you have to do some specific type checks when you are dealing with an angle side-side case. Okay? So the first thing is if the given angle is obtuse. So if I have a given angle, so if my given angle here and my side, there's my angle side. Okay? So this one we will call the opposite side, and this one we will call the adjacent side. So if my opposite side is greater than my adjacent side, and my angle is obtuse, I get one triangle. If my adjacent side is longer than my opposite side, so that would probably look something along the lines of this. Can I get a triangle? Can I make a triangle out of those three sides? No, can't do it. Okay? Remember we talked about this yesterday. Longer sides are produced by bigger angles, right? Can I have two obtuse angles in a triangle? No. Okay? Can't have two obtuse angles in a triangle. So the angle that's opposite the obtuse angle has to be the longest side. The side opposite the obtuse angle has to be the longest side. I think I said angle twice there. Okay? So that's one check. If our angle is obtuse. If our angle is acute, okay? If our angle is acute and the opposite side is greater than the adjacent side, we get one triangle. If our adjacent side is longer than our opposite side, actually here, let me do the go with this way, and then oops, that jumped up on me. Here we go. And then make these nice and straight. Okay. So my angle is here. This would be one of my sides, which is my adjacent side. And then out here, we have another side that's my opposite side. Okay? So now my adjacent side is longer than my opposite side. The kicker here is you have to we'll go green. You have to look at the height. You have to look at the height of your triangle. Okay? And we can easily find the height of our triangle using the sign, because it becomes a right triangle, so we get the sign. Okay? So there's three possible scenarios here. The first scenario is if that opposite side is equal to my height. If this opposite side here is equal to my height, then it swings down here and it creates one right triangle. Okay? Second scenario is if the opposite side here, actually let me make this be red, then we can see it a little bit better. Okay? So if my opposite side there is shorter than my height, will I get a triangle? No, because it'll never close off here. This will never close off on that triangle to make it work for me. Okay? So this is a no triangle case.
Won't happen.
Won't happen.
I just came in to back you up on that.
Thanks.
It will not close.
Your support means the world to me.
I know.
Have a great day, Mr. Steckbauer.
You too. You guys too. And remember, hey, it's not closing.
It's not closing. Hey, you got to close that door, man. Okay? All right? So this third case, where the opposite side now is longer than my height, right? So now this is that funky case. This is where I'm going to get two triangles, because one triangle is going to be over there, and then the other triangle is going to be down there. So I'm going to get two distinct triangles. Okay. Now, that's a lot of information, and I told you that I would do it in 27 minutes, which means I get to sum it up in 2 minutes. What's up?
Is the angle produced by the outside, the black line there, the same as the angle produced by the red line inside? Triangle?
Over here?
No, the other side.
This one?
Yeah.
These two right here?
Or those?
No. They are not the same. Yep. No. Because then that would mean that these two would be supplementary, which means that these two would be supplementary, which means I wouldn't have an angle up there. Because it's got to be 180. Okay. All right. So, to sum it up, in a nutshell, when we're dealing with our angle side sides, okay, if my opposite side is longer than my adjacent side, we will always get one triangle. Always. If your opposite side is bigger than your adjacent side. Obtuse angle, acute angle doesn't matter. Okay? you'll get one triangle. If your opposite side is less than your adjacent side, we could get 0 triangles. We could get 1 triangle, or we could get 2 triangles. We have to check our height, because that's going to determine 0, 1, or 2 if our angle is acute. Oops, that should be angle, not triangle. No triangle if the angle is obtuse. Okay. We made it through. Okay? Now, let's do an example. We'll refer back to that in a minute. Okay? So, example number 2 says, solve the triangle. Angle A. Does it matter where angle A goes? No? Okay? I'm going to put it here. Angle A is 42 degrees. Side A is 22. We'll call this angle B, which would then that would be angle C. And side B is 12. Okay? So, first check is this an angle side case? Yes? Yes, it's an angle side case. Okay? That means the ambiguous is still in play. I could have 0, 1, 2, or 1. I almost said 3 triangles. 0, 1, or 2 triangles. Okay? All right? Second check. What kind of an angle am I given? That's an acute angle. Okay? So I'm still in the ambiguous case. 0, 1, or 2. Okay? Third check. What is the comparison between my opposite and my adjacent sides? Which one? Opposite is bigger. Okay? So going back to my handy dandy wrap it up page, opposite is bigger. 1 triangle. Fantastic. That means we got 1 triangle. Find me, solve me for angle B, angle C, and side C. Okay? Go for it. So these are what I got for that triangle while we pick on Mr. Steckbauer about not responding to emails. Angle B I found first. 2 decimals is fine. I put 4 on there just because I put 4 on there. Okay? So 21.41 degrees for angle B. Found that one first because you were able to find that one first. That completed the. Then we could find angle C, knowing that all 3 angles add up to be 180 degrees. Okay? And then we can go back and we can find side C. Okay? Now, just so you are aware, on this one too, and on like all my answer keys and stuff like that, I don't round. Okay? So I left this, even though I only put it as 4 decimal places here, there was like 15 on my calculator. Okay? And then I went to this one and I didn't round it. I kept it on my calculator. And then I left it on my calculator. I did all my math behind this, and then I, used the answer key on my calculator. Okay? So you might be off by just a twinge depending on where you round. Okay?